Hello, good evening, everyone. So, beta, welcome to the second session of full microeconomics revision. Now, as all of you, as I just confirmed this morning, also, you may be aware that I had given you the first numerical sheet to be done with the session that I had taken, and I hope that all of you have done that numerical sheet. If not, then the first thing that you do today after this session is go through those numericals that I had given in the last marathon. The solution to those numericals are also posted on the portal only under microeconomics section. Towards the last, you will see the solution of those numericals also. So all of you have to go ahead and do those numericals. Now, the second thing which is important is that today again, I have gone ahead and I have prepared a numerical sheet. This has a lot of numericals in it, and all of you are supposed to do these numericals today itself. This is very, very important for the preparation of our MA Economics entrance exam. So all of you will go ahead and prepare these numericals. I will go ahead and upload the solution also just below the numerical sheet after today's session. And, I hope that you will definitely attempt these. Now, I hope that all of you have also got the second, revision notes. And I think they have been already posted on your Telegram group. Can you just confirm me once? Just say yes or no if you have them on the group. Okay, great. So you can just use these notes for the second part of microeconomics revision. Okay, good beta. Let's start then. So just read this through and I will just come to ICC and angel curve directly. So now just try to understand that whenever we talk about the type of goods, we can divide the type of goods in three parts. तीन तरीके की goods हो सकते हैं. It can be a normal good. It can be an inferior good. And it can be a given good. Now, both of these, they obey the law of demand. And this is an exception to the law of demand. So what can come in exam, mathematically bhi aa sakta hai, they may ask you, derive the equation of angel curve or derive the equation of your demand curve. Or they may ask you, derive the equation of income offer curve or price offer curve. Like that, they can ask you in exam. They can give you 4 options and they will ask you, what is the equation? Which of the following represents the equation of the angel curve? So in this case, we have to be very sure that when I am talking about my income offer curve, this is showing different combinations as your income is increasing. So I have my budget line and I have my indifference curve and I have this as my equilibrium. This is my equilibrium. Now, when my income increases, my equilibrium will go upwards. Joining these equilibrium points, I will get my income offer curve. So I am joining different equilibrium points now. And how do I represent this equilibrium point? This equilibrium point is where my MRS is equal to PX by PY. So I am joining the locus of all these tangent points, right? That is giving me my income offer curve. And if I just go ahead and I take income on one side, एक side पे मैंने सिर्फ income ले लिया, and I take the demand of the good on the other side, then what will I get? I see that if it is a normal good, then the demand of the good will increase as my income increases. So I will get an upward sloping angel curve. Angel curve क्या बता रहे बच्चे? It is telling me different combination of income and demand, है ना? So when income is M1, your demand is X1. When income is M2, your demand is X2. यही तो एंजल कर्व बता रहा है. So if you remember, let's say I have a utility function XY. We know that if the utility function is XY, तो बच्चे what will be X star? It will be M by 2px. What will be Y star? It will be M by 2py. So we know that X is actually a function of income. And from here only I can see that when my income will increase, income numerator में आ रही है, as my income will increase, the demand of X will increase. So this also guides me to the fact that X is a normal good. Because as your income is increasing, your demand is increasing. Achha, now just think about it. Suppose I have income here and I have X here. And question में वो पूछ लेते हैं in exam that find the slope of angel curve. तो angel curve क्या बता रहा है? Angel curve is giving you the equilibrium combinations of income and good. So the slope of this angel curve will be nothing but change in perpendicular by change in base. Change in perpendicular will be what? How income changes. Change in base will be what? As X changes. So ideally, अगर मेरे पास मेरा equilibrium bundle है, if I have this equilibrium bundle, then can I not just go ahead and find dm by dx from here? That will be the slope of the angel curve. So such questions can be asked in exam. They can ask you find the slope of angel curve, find the slope of the demand curve. Demand curve hoga, then I am plotting it between price and X. So iska slope will be dp by dx, right? So they can go ahead and ask you the slopes of angel curve, demand curve, and you should be aware कि कौन सा curve कौन से कौन से x-axis and y-axis coordinates पे plotted है. What am I taking on the x-axis? What am I taking on the y-axis? Another thing that is important here is what happens. So I have been seeing this doubt a lot. What happens to price offer curve for normal, inferior and given goods? Price offer curve के बारे में, right? Just think about it. But this is a very tricky question for normal goods. समझो जरा ध्यान से. If I have this as my budget line, AB is my budget line, and I draw one equilibrium point. मैंने यहाँ पे अपना equilibrium point draw कर दिया. Point E is my equilibrium point. Now, the question tells me that price of good X has decreased. It means that my budget line will pivot outwards. Budget line बाहर की तरफ चली जाएगी. If my budget line will pivot outwards, then if it is a normal good, I know I have to increase the demand of good X. मुझे X की demand को increase करना है. I have to increase the demand of good X. But this is where the issue lies. क्योंकि just notice here, beta, if I draw my new equilibrium point here at E1, then also I have increased the demand of good X. ध्यान से notice करो, demand of good X has increased. So price of good X decreased, demand of good X increased, fine. Now just think about it. What if I go ahead and draw my equilibrium point at E2? Then also I've increased the demand of good X. ये भी ठीक है. What if I draw my equilibrium point at E3? Then also I've increased the demand of good X. So whether I go from E to E1, I have increased the demand of good X. Whether I go from E to E2, I have increased the demand of good X. Whether I go from E to E3, I have increased the demand of good X. So beta, that ways, अगर मैं इनको join करती हूँ different points को, what will I get? Well, if I join this, I will get upward sloping price of a curve. If I join this, I will get horizontal price of a curve. If I join this, I will get downward sloping price of a curve. In exam, if they ask you that the price of a curve of normal good is, please don't write upward sloping. हमेशा upward sloping नहीं होता है. तीनों ही केस में when the price has decreased, I have increased the demand of good X. It is obeying the law of demand. But in all the three cases, I see that the shape of the price of a curve that I get differs. तीनों में price of a curve का जो shape बन रहा है, that is different. Right? But this is very tricky and you should be well aware of it. बाकी given goods में the price of a curve becomes backward bending. Right? And inferior good, so they also obey the law of demand. So when price of this good will decrease, its demand should increase. We don't have any issue there. But only here, for given goods, it will be backward bending. That is another thing that you have to remember. ये चीज भी याद रखनी जरूरी है. So that is it that I have here. Then beta here just come to this box. Equilibrium will occur where slope of IC is equal to slope of budget. And that's correct beta. But वो new indifference curve कहाँ पे होगा वो तो differ कर सकता है ना. So my new indifference curve can pass through E1. My new indifference curve can pass through E2. My new indifference curve can pass through E3. नया IC कहाँ होगा that can be different ना. I am joining the equilibrium points only जहाँ पे ये tangency है. That is what I am doing. But वो indifference curve where that will be, that can differ. Right? So accordingly I can get different POCs. Is that clear now? Okay. Okay. Now this box I have explained you last time, so I'm not repeating this box again. Just go through it. Acha, now this is very, very important and I have given you a numerical on this also. This is what is compensating variation versus equivalent variation. In very, very simple terms, ध्यान से समझ लेते हैं एक बारी बेटा. Compensating variation keeps utility at original level. Just for example, I have given this example multiple times in live class. There is this individual. This individual is living in city A. He has a utility function. City A में price of good X is given to you. Price of good Y is given to you. You are given his income. अब क्या हुआ? His company, he told him that we are transferring you to city B. हम आपको city B में transfer दे रहे हैं. In this city B, जिस city B में अब वो रहेगा, in city B, his utility function is same, जो भी आपको दिया होगा, but city B is very expensive. जैसे imagine, if this person goes from say Delhi to Bombay, and Bombay is expensive, Bombay ज़्यादा महंगा, it's expensive. The price of good has increased. It has changed. It has increased. So, suppose यहाँ पर after consumption, his utility was 2,500. Now, if the price of this good has increased, this city is expensive, it means that he will be able to afford less goods. कम खरीद पाएगा. If he will be able to afford less, his utility will decrease. उसकी utility भी गिर जाएगी. Now, this person is worse off. He doesn't want to go to city B. So what will this company do? This company will say, okay, you go to the city B, but I will give you some additional income. मैं आपको कुछ और पैसा दे देती हूँ. But I will make sure that you get the same level of utility. If you were getting a utility of 2500 here, अगर आपको 2500 का utility यहाँ मिल रहा था, I will ensure that you get the same utility here, even though this city is expensive. This is called as compensating variation. The extra income that this person will get, जो उसको extra पैसा मिला, the extra income he will get. Why will he get extra income? Because city B is expensive and he wants the same level of utility. उसको same utility चाहिए जो पहले मिल रही थी. The extra compensation he will get, that is called as compensating variation. Am I clear with this? I have given a numerical on this concept using the same example. Everyone will try that. So compensating variation says the extra money you are getting ताकि आपको same utility मिल पाए, so that you can get same utility as before even when prices have increased. That is called as compensating variation. So we are holding utility at the old level. हम यूटिलिटी को ओल्ड लेवल पे कंसिस्टेंट रख रहे हैं, कांस्टेंट रख रहे हैं. इक्विवेलेंट वेरिएशन विल डू द ऑपोजिट. इक्विवेलेंट वेरिएशन will hold utility at new level. Right? It will say, अच्छा okay, city B में अगर सिर्फ 2400 की ही यूटिलिटी मिलती है तो सिटी A में 2400 के लिए इसकी इनकम कितने से कम करें? How much should his income be reduced so that he gets the same utility as the new level, so that he is indifferent कि यहाँ पे भी इसकी पैसा गिरा दो ना, अब तो he will be ready to go to the new city. That is equivalent variation. So in compensating variation, you will hold utility at the original level, right? Even at new prices, you want him to get the old utility. So you will go ahead and give him more money when price will increase. In equivalent variation, you will hold utility at the new level. I hope this is clear to you. I have provided a numerical, please do that. So this concept, beta, it is explaining you compensating variation only. Now come below, just come below. And here I want to talk about risk before I go further. Okay. Now just listen to me. In risk, you should be aware of the following concept. Pehla, you should be aware about expected value. That's the first thing that can be asked in exam. Expected value बहुत basic है. If I tell you that the probability of accident is 10%, and under accident you will get 0, and the probability of no accident is 90%, and no accident में you will get 10,000, find expected value. ये पहले तरीके के क्वेश्चन हो सकते हैं. So 10% into 0 plus 90% into 10,000 and you will get expected. The second kind of question that can be asked in exam. Okay, beta, towards the last I will show you a numerical on CV and EV. Okay, I will take you through that numerical sheet question. Don't worry. Just remind me towards the end. Okay, so this is expected value. Then the second kind of question that can be asked in exam is expected utility. So expected utility mein you will be given a utility function and you will be asked to calculate expected utility. तो उसमें क्या होगा ना? So if I were to find expected utility, I will be having 0.10 root 0 plus 0.90 root 10,000. That's the second kind of question. Now, post this, if you remember, we did a concept of risk premium. And हमने ये बोला था कि risk premium is that amount which a consumer is willing to give in order to avoid risk. जो पैसा वो risk से बचने के लिए देना चाहता है, the amount he is willing to give in order to avoid risk, that is called as risk premium. In this concept of risk premium, we did three kind of individuals: risk averse, risk lover, risk neutral. And we said that if an individual is risk averse individual, मतलब वो तो risk definitely avoid करना चाहेगा, he wants to avoid risk. So for this individual, the risk premium will be positive. He will give you money in order to avoid risk. वो बोलेगा मुझसे पैसा ले लो, but I don't want to take risk. A risk neutral person will have zero risk premium. He is neither willing to give money nor does he need money. And a risk lover individual will have negative risk premium. Why? Because he wants to take risk. तो अगर आपको उसको risk लेने से बचाना है, you will have to give him money if you want him not to take risk. So we talked about the concept of risk premium, where we said why risk premium can be positive, negative or zero. इसकी हमने बात की. Now, the next thing that can be therefore asked in exam is calculate certainty equivalent. Right. Again, I want you to practice numerical sheet today itself. There is a question on certainty equivalent in the numerical sheet. What was certainty equivalent saying? Certainty equivalent says that, look, if a person is taking risk, then he is getting some utility. मतलब मैंने risk लिया, आपने मुझे बोला, look, you have to go in this house and this house may fall and there is 10% chance you may die. Then also I went into this house. So when I am taking risk, I am getting some utility. Say my utility is 50. There may be a corresponding situation when I don't take risk and I get the same level of utility. What is that money which will give me the same level of utility as this? That is what certainty equivalent says. तो हमने इसको कैसे calculate किया था? I will just show you through this example. If you remember, this was my curve. ये हमने एक curve बनाया था. And then we said, look, this is two scenarios. ठीक है, एक में आपको कुछ money मिल रहा है, दूसरे में कुछ मिल रहा है. We had gone ahead and taken its weighted average and we had got up a bundle here. This was called as the weighted average bundle. We were getting some utility from this and this was called as expected utility. That money which gives you same utility as this expected utility, but that money is certain. यहाँ पर जो पैसा है, जो आपको same utility देता है as expected utility, that is called as certainty equivalent. I hope you remember these concepts. So certainty equivalent word में आ रहा है. This is the certain amount, fixed amount that gives you utility equivalent to expected utility. Right? So you will find your expected utility first. And then you will say कि ठीक है, if my expected utility is coming as 400 and my utility function is root of W, so which wealth will give me 400 with certainty? You will just equate root W to 400 and you will get W as 400 square. This amount will be called as certainty equivalent. ठीक है? So we are saying कौन सा ऐसा पैसा होगा जो same utility दे as expected utility. This is very important from exam point of view and this will come in exam 150%. Then the next thing that can be asked in exam from this chapter is to find out insurance premium. But please revise this chapter as many times as possible. It's an important one. And actuarially fair insurance. So we had said that, fair का मतलब ये है that you will pay premium equal to probability of loss into size of loss. This is the formula for actuarially fair insurance. So for example, if I tell you that there is this person and there he can get heart attack 10% of the time. If he gets heart attack, he will not be able to work and he will lose 50,000 wealth. 90% of the time he will not have any heart attack and his wealth will be say 2 lakh. And the question is asking you calculate actuarially fair insurance premium. ऐसा कुछ बोल दिया कि actuarially fair insurance premium निकालो. So actuarially fair insurance premium will be probability of loss. Beta, what is the probability of loss? 10% of the time. And the size of the loss. So मेरा loss कितना हो रहा है? My wealth is 50,000 when I fell ill. My wealth is 2 lakh when I am fine. So I am losing 1,50,000 now when I am ill, when I am sick. So my size of loss is 1,50,000. When you will multiply the size of loss with the probability of loss, that will give you actuarially fair insurance. बहुत important है. एक simple just दो numbers को multiply करके answer आता है. It's an easy calculation problem. Therefore, it can be asked as part of MCQ. It can come in exam. So we have to be very sure of this concept. These are few of the concepts. Plus, there is an assignment on uncertainty. जिसमें there is a question on arrow-prat. Please do that assignment and do this arrow-prat. Know the formula of arrow-prat also. हाँ, वो risk aversion calculate करने का formula है. Write down. इसी पे कहीं पे write down in your registers that you have to read that assignment question and do this arrow-prat numerical. Okay, now just come, please do these things today itself, beta. We don't have enough time to revise this again. इसके बाद दोबारा time नहीं मिलेगा that you open up micro because I will move on to the next subject. So it is very important that you do this with me. Now we talk about production theory. So production में law of variable proportion, law of returns to scale. Returns to scale is a long run concept. Variable proportion is a short run concept. Now, you can just go through this. This just says that as you increase your input, the output, marginal output decreases. That means marginal product of labor is diminishing. ये बोल रहा है. You can just go through this. This is basic. I want to talk about this. This will come in exam. Important. Very, very important. देखो, all of us are aware about the 3 returns to scale. So we know that when it is increasing returns to scale, if you will scale your labor and capital, then your output will scale more than alpha. ये हमें पता है. जैसे example, if I take my production function as L square into K, तो जब मैंने labor और capital को double किया, my new output will be 8LK. So it will be 8 times the 8L square K. So it will be 8 times the original level of output. I only doubled my inputs, but my output became 8 times. This is increasing returns to scale function. ऐसे ही हमें constant returns to scale and decreasing returns भी we are clear with it. So constant returns to scale will look something like this. Y is equal to L to the power half, K to the power half. And decreasing will look like this. L to the power 1 by 4, K to the power 1 by 4. You can also see by adding the powers. The sum of the power is less than 1. So this is decreasing returns to scale. Equal to 1, constant returns to scale. Greater than 1, increasing returns to scale. But in exam, they will go ahead and they will ask you question related to the gap of isoquants based on the returns to scale. They will ask you, suppose this is an increasing returns to scale function. ऐसा कुछ दे देंगे. Suppose it is increasing returns to scale, then the isoquants will be equigap, less gap, more gap, something like that. ऐसा कुछ क्वेश्चन आ जाएगा. So this is important that if it is a constant returns to scale function, your isoquants are equidistant. Please mark this important in your sheets. If it is decreasing returns to scale, the distance increases. Decreasing returns to scale, isoquant distance increases. Increasing returns to scale, isoquant distance decreases. Please take out a printout of this sheet and write down important here, beta. This is very important. 150% I can tell you in one of the entrance exam, this MCQ will be asked. Okay. Then we know what an isoquant is. The slope of isoquant is MRTS. This is nothing but MPL by MPK, right? And beta, जब भी MPL by MPK लिखो, make sure that you know L is here and K is here, right? So just remember that by default, when I take capital on y-axis, that is when I will have marginal product of labor in the numerator. That's also important. Okay, now come to the next sheet. Just like the elasticity, just like the indifference curves, isoquant can also have this function. मतलब ऐसा कुछ हो सकता है that Q is equal to min of LK. Q is equal to alpha L plus beta K. So you can have labor and capital complementary. You can have labor and capital as substitute also. Now here, another kind of question that can be asked in exam is this. Find output elasticity of input. Just for example, they give you a function like this. Q is equal to 10 LK. They're asking you find output elasticity of labor. हाँ बेटा. To do this question, there are two ways. दो तरीके हैं इस क्वेश्चन को एड्रेस करने के. Number one, I use the definition. So this is saying output elasticity of labor. मतलब how output changes as labor changes into initial value of labor by initial value of output. ये elasticity का formula है. I am just using this formula. So if I differentiate this with respect to L, I will get 10K into L by Q. तो ये हो जाएगा बच्चे 10LK by Q, Q by Q, 1. एक तो ये तरीका हो गया, simple. I am just using the basic formula of output elasticity of labor. Second formula. It is asking me calculate output elasticity of labor, and it can be calculated using this formula. Marginal product of labor divided by average product of labor. ठीक है, वो करके देख लो. You will get the same answer. What will be marginal product of labor? Differentiate this with respect to L. Differentiate this with respect to L. This will give you 10K. What will be average product of labor? Output divided by labor. This will be 10LK divided by L. That means 10K. So what will be MPL by APL? It will be 1. Divide this by this. You will get the same answer. So both of them are giving you the same answer. Sometimes in exam, they will just ask you this formula. So this formula is equally important, that the output elasticity of input is MPL by APL. This is very important and you should be aware of this. Okay. Then you have becha homogeneous function. Any function जिसमें हम scale करके factor को बाहर निकाल पाएं, m को बाहर निकाल पाएं, that's a homogeneous function. Then in exam, isn't it simply the power of L here? So if you go ahead and you look into it, you can also go ahead, correct, that's right. You can also go ahead and you can also look by looking into the powers. And you can go ahead and say that that's the power. Absolutely, that's also correct. There is nothing wrong in it. Correct. Can it be in terms of capital? Yes, yes. In any input, किसी भी input के लिए you can go ahead and find it in terms of capital. This can be MPK by APK also. If you have given, अगर land दिया हुआ, it can be MPT by APT. Any factor you are given, correct. So because you highlighted that it can be power of labor or capital, I just want to highlight that, that is only possible if it is a Cobb-Douglas function. But what if it is not Cobb-Douglas? What if I'm given some other kind of function? What if I'm given this, that Q is equal to LK plus L? Then I have to go ahead and calculate, right? So then this formula is very handy for me to go ahead and solve. Okay, beta. Okay. Now let us go ahead and let us talk about the Cobb-Douglas production function. The Cobb-Douglas, this can come just as part of GATE or CUET question, that it was first introduced in 1928. And then you just have to remember that, the Cobb-Douglas production function, generally, whenever I write this, I will write it like this: L to the power alpha, K to the power 1 minus alpha. This is the initial production function we had. So if I write it like this, then you can clearly see that it is a CRS function because the sum of the power is 1. And as I have written here also, alpha tells the output elasticity of labor and beta tells the output elasticity of capital. So ये काफी important हो जाता है that you go ahead and remember these properties. These are some of the other properties given of Cobb-Douglas function. Please read through them. They are very, very important from the point of view of exam. This has been asked multiple times in exam, and we should be well aware of the Euler's theorem. So Euler's theorem, what does it suggest now?